Hi there. Hi,
Hi,
everybody.
cool.
Thanks, Helen. So just to introduce myself, I'm moderating this session before I hand over to Maddie. So some of you may have heard of Quark. You may have seen us at the KM World, and we sponsored a taxonomy bootcamp there at the back end of last year. But we specialize in enterprise content lifecycle management solutions. So we do everything. So many of you have heard of structured authoring, structured content authoring, and CCMS and terms like that, where you're building blocks of content and using it for structured purposes. So that's where we get involved in the taxonomy side of things. So it's an absolute pleasure to sponsor things today. And if anybody wants to explore that, as I say, we specialize in highly regulated industries, such as financial services, life sciences, government, heavy manufacturing, and things like that. So it's a pleasure to be here today. Thank you, Helen. And I'd love to introduce Maddie. So Maddie is Head of Client Solutions and Services at Graphify. They're a knowledge graph, semantics, and data management startup company. And Maddie is a creative technologist specializing in DAM, enterprise taxonomy and ontology development, information architecture, and digital strategy. And Maddie's going to talk to you about a simple knowledge organization system and why do you need to know what it is. So without further ado, let me hand over to Maddie.
Thank you, Emerson.
Sorry, Maddie,
yeah.
Did you want us to keep our cameras on, or do you want us to disappear so you've
No,
got
you can
whole
do what
stage?
you want. It's up to you, really. Okay. Thank you. So I'll go ahead and share my screen. Thank you, Emerson, for that kind introduction. And thank you, Helen, for having me here at this Bite-Sized Taxonomy Bootcamp and for including me in your organization with these esteemed and excellent speakers today. It's a real privilege to be here grouped with you. And I have, again, another privilege of closing out the Taxonomy Bootcamp to talk about the exciting world of standards. Oh, now, don't run away. I know standards can be very boring, but standards are actually very, very important. And we'll go over some of the ways that it can actually set the foundation for your organization or your enterprise. Let me move this a little bit. Okie doke. Agenda. Hold on. Now, I know that we're in a community of taxonomists, and I'm very, very happy to be among you. And again, I want to thank Helen also for keeping this community alive. We're a small niche group. And so it's a lively group here, and it's a real pleasure to be here. If you're a taxonomist and you are using taxonomies to be able to share vocabularies, to be able to manage keywords and share them across multiple systems, or perhaps you're using a taxonomy as a navigational tool to be able to navigate across many pages on a website, or you use a faceted classification, as Ed just beautifully exampled, where you can start mixing and matching different genres to get something specific for you. If you don't use some kind of a standard that is machine readable, what you're basically just doing is a text search. And a text search is, the computer is just looking for that combination of letters within a word. It really doesn't know the meaning of the word, and it doesn't really care. It's just looking for that combination. And while that can work, it's very, very limited. And as Ed just also talked about, how we're all drowning in content. We're drowning in content, we're drowning in data and information. And the way to be able to cut through that in the easiest and fastest way possible, I think, is a goal of all of ours. So what is SKOS? SKOS stands for Simple Knowledge Organization System, and it was released way back in the day in 2009. It's a W3C standard, so it was put together by a group of experts. Why bother with this? Well, using the standard was built and developed to be able to promote interoperability within different pages on a website, within different systems, within organizations, and even beyond. It supports a semantic web so that when you're ready, you can also probably pull in outside resources that might be pertinent to your enterprise or your organization. It supports linked data principles And this improves search and retrieval as well as faceted browsing. But most importantly, it enhances data integration and relationships. SKOS as a standard is non-proprietary, and that's one of its superpowers. If you are working within a repository or a data repository, and the way that it expresses its own content or its own metadata, if it's proprietary, then what you have is a siloed system. It can't really interoperate with the others, and it can't reference other information from other systems that might be relevant, and you're locked in. And for those of us who have lived through some of the times when there were proprietary databases, you actually had to pay the databases in order to retrieve your content because they were the only ones who were able to get it for you. Thank goodness we've moved away from that, and most organizations now own and manage their own data. And what kind of data or terminology or vocabularies might you want to share across your organizations? Well, I'm in a room full of taxonomists, so I know that you are already doing this, but some examples might be the names of the people, some organizations that your company works with, the products. That's very important. If you sell your products on multiple platforms, then you want to make sure that your products are spelled correctly and that they have the information that's required of them about what the product might have in it, ingredients, for example. Events, locations, geographic locations, all of these are things that would be worth it to share across the organization. Not only that, with a standard like SKOS, one is able to harmonize different dialects or different terminology across different divisions or even countries. Lorry, truck, anybody? Courgette, zucchini? Those are the same concepts, but just different ways of expressing them. And so you can use the SKOS standard to be able to harmonize. It also allows for different, putting in different internal acronyms that internally you might know, but if you take that acronym out to your customers, say on a website, they don't speak that way. So they really have no idea what you're talking about. And I've been through many board meetings where I really don't know what people are saying because the acronyms are flying. And then most importantly, SKOS requires a unique ID, which is usually a URI. We can go a little further into that later on. We've talked about how SKOS will help AI and LLMs throughout this entire session. It's at the top of everyone's mind, and I think we can all agree, and we all realize that LLMs and AI and machine learning actually rely on a human in the loop and someone who knows about what it is that the domain is trying to represent. And so the baseline of AI is knowledge organization. And with SKOS, it helps you to come up with the first steps. Now, one of the things I loved about Joyce's MVT is starting out small. Start out small. There's no need to start out big. One of the great powers of SKOS is in its relationships. And so it's always good to know what kind of data are you looking for before you begin. If you start putting everything in all at once and then expect to find a eureka moment, you'll probably be very disappointed. So it's always good to start out with a very measured response to how you want to begin building your knowledge organization system. SKOS is also very important by introducing what they call the semantic layer. And we'll talk about that in just a minute. The semantic layer, well, what is it? It is a standardized framework that organizes abstract data. And that could be data from anything, from structured to unstructured to semi-structured, from multiple places, multiple systems, so that we can begin to build the relationships of relevant data from other systems. By managing these relationships, we begin to really give the power of querying for business outcomes so that you can ask very sophisticated questions like, what product sold the most in Wisconsin in 2009? And that would be hard pressed to find in a relational database. But with a knowledge organization, I would say like an ontology or a knowledge graph, these queries become easier. Here's a quick graphic of what that semantic layer does and where it sits. Where at the bottom, we have the data sources. These could be any kind of repository. They could be your PIM, your product information management, your customer relation management system, your DAM, your digital asset management system, or your place where you keep all your games. Anyways, these are the mother loads of the product that you're going to be managing. A machine can actually access each of those systems and pull the metadata out of it. And once they pull the metadata, they can begin, they, meaning the machine, can get an idea of what kind of stuff is in that box. What's the metadata that they're using it? How are they expressing it? How are they describing the content in that particular system? Once that metadata is extracted by turning that into a standard, a SKOS standard, one can begin to start to build relationships without having to penetrate the system itself, because we're just playing and making relationships between the concepts, not the actual objects, but a way to retrieve those objects depending on how those descriptors are used. And the outcomes is for the organization or your customers to be able to do sophisticated queries. And every single session talked about, the different ways of being able to manipulate that in order to find the right recommendations, not just for the content, but the right content to the right person. Ontologies provide a structured way to represent knowledge. We talked a little bit about how LLMs were the aliens, and ChatGPT was scraping information from across the web from everywhere and everybody. But more organizations, as Emerson actually spoke about very early, most of the clients, and I find this true for myself too, are interested in using LLMs as their own sort of walled garden, in a trusted garden where they know where the data or the content is coming from, and they can begin to build those LLMs with the trusted data. And so they start there. So you define the concepts, you define the relationships, you define the categories, and you come up with your domain. And that domain is your garden. We're not talking about anyone else's garden, but your garden. And it allows the ontology to be able to represent your garden through organizing the content and the data, disambiguating things that have very nuanced meanings that need a little help for a machine to understand, and it contextualizes the data so that we know exactly whose garden we're in. Well, I think my other colleagues have come up with the better answers for this, but SKOS's role is no different from structured metadata and structured taxonomies and knowledge that can help LLMs, machine learning, and AI. SKOS allows for an enormous amount of flexibility. It's not a standard in a way that you have to apply it. With ontologies, it's very flexible. So you can customize it to be able to build relationships of a domain-specific garden that makes sense to your enterprise, your organization, or perhaps even to your industry and to your sector. It enhances learning and adaptability. This means it helps the machine learn with a human in the loop and correcting sort of auto tagging through entity extraction, say, which is usually the first step with AI and machine learning, with a human always there or a subject matter expert being able to validate or to decline the first pass of any machine learning. The machine begins to learn and it begins to adapt. And as it continues on, it will actually get smarter and will get faster at doing what it does. Scalability and efficiency. Relationships can be very, very complex. especially, I mean, I think Dave was talking about over 1 million different concepts in a taxonomy tool. That's more likely something in life sciences or pharmaceutical. It's a very complex domain, and having complex relationships really can't be done in a relational database. Instead, they're better served in an ontology or a knowledge graph. Okay, most of you probably know this, but a good refresher is always good to have. As my father used to say, repetition means retention. So let's continue with the basics of SKOS. The basic is that everything's a concept. I think Dave also talked about the transition from term-based management, conceptual or concept-based relationships. And this is exactly what SKOS is the bridge for. So what is a concept? It's a unit of thought. It could be anything. And these concepts will be expressed in RDF, which is a kind of language, and we'll go into that in just a second. And each concept will have a URI, or a Uniform Resource Identifier. This is not that different from every term in a taxonomy, would also have an identifier, but with SKOS, they like to use the URIs or an IRI, which looks like a web page address. But this anchors the concept in a place that makes relationships easier to maintain. What's a concept scheme? Concept scheme is a bunch of concepts, just a whole bunch of them. And SKOS provides a way to be able to group different concepts and organize them in a way that makes sense for you. Labels. A concept can have many labels, but there are rules in SKOS. For instance, you can only have one preferred label per language. You can't have two preferred labels in English. So instead, you should choose which one is the preferred. And the reason for that is part of trying to get people to slowly start tagging or using the preferred label. And rather than putting harsh rules, SKOS allows some different dialects. So you can have a preferred label. You can have a preferred label in each different language that's important to your organization. You can have an alternative label. And you can also have hidden labels. When we talk about harmonizing vocabularies across an organization, and I'm sure all of you have come to terms with the fact that different departments may have the same thing, but have completely different ways of describing it. And so SKOS also allows and supports different ways of harmonizing these labels. So you can use SKOS for synonyms, for abbreviations, and acronyms, languages, and hidden labels. And hidden labels are usually used internally. For example, there might be a product that has an old name or even a division within the organization that isn't called that anymore. Human resources is now called the People First division, but you might have a lot of information and resources that are labeled with the legacy label, but you don't want people to use it anymore. So we use that as an internal hidden label. Now, SKOS doesn't just give you relationships. They also allow for different ways of describing the concepts themselves. There's more meta. It's not just a concept. We might want to know actually where is this concept in an approval process, for example. There are 7 notes properties in SKOS. They are scope notes, change notes, notation, editorial notes, and history notes. Now that sounds like an awful lot of notes, and you don't have to use them all, and you may not need them in your organization, but some people do. This is an example of the Getty Art and Architecture Thesaurus, and they use all of them. Because this was built from a consortium of international museums around the world, They have an enormous amount of citations. This is just the notes page of a term called Ushabti. And Ushabti is an Egyptian funeral sculpture that was small, that was usually sent with the deceased into the tomb. And it was thought that it was a kind of, it would help them in the afterlife. I think how it would help them in the afterlife is up for debate and scholarly research. However, here you can see the note of the definition of what they could pretty much agree on, and the different ways of different languages of how they can spell Ushabti and how it's used. Over on the right, you can see its deep hierarchical position within a taxonomy, and then additional notes, and then finally, the sources from which this information came from. And these are all SKOS compliant. The beauty of ontologies. Ontologies is a formal system for modeling concepts and their relationships. I think a lot of people like to say that ontologies make relationships a first-class citizen. It's not an afterthought. The relationships are actually the most important part of an ontology. But an ontology doesn't necessarily dictate what those relationships should be. So that's usually up to the taxonomist or the ontologist to be able to pull that together and build relationships for data that you're going to want in the future. And so they do more than just hierarchical relationships. Ontologies are expressed through RDF triples. And it's a beautiful and profound thing, a triple, because it's the simplest way to build relationships through subject, predicate, and object. Looks simple, very powerful. So one could say, Madi, that's me, the subject. Isa is the predicate, which builds the relationship and tells you exactly what kind of relationship we're talking about, to the object, which is taxonomist. Madi is a taxonomist. The bite-sized taxonomy bootcamp, which is probably in the category of events, occurred on the state. Banjo is a musical instrument. So whereas a taxonomic rule is relegated to the broader and the narrower and the related term, an ontology can be expressed in whatever you want to. You can bundle things together. You can say whatever kind of relationships that you want, that related to, has worked for, is located in. It's endless. The relationships. I'm sure most of you are now completely aware of taxonomic semantic relationships, which is at its best a hierarchical one with a broader and a narrower, a parent term and a child term, and then a sibling or a related term. Some broader, narrower hierarchies are incredibly deep, as you can imagine. Yes, for life sciences and pharma, they can be incredibly deep and extremely polyhierarchical. So they're everywhere. But the basics of the relationship with SKOS is really the broader and the narrower and the related, just as they are in taxonomies. Now, while SKOS has broader and narrower, those are inverse relationships. That means that with SKOS, that data can express itself. It can say to the computer, I am a narrower term to this broader term. And inversely, that broader term could say, I'm a broader term, and here is my narrower term, or these are my narrower terms. And that relationship is inverse. SKOS takes it one step further, and they have broader transitive and narrower transitive. And this is the beginning of the power of inference. Don't go lightly here, but it is incredible what this can do within a knowledge graph. So what is transitive? Transitive means that you can identify a property to inherit the relationships within a hierarchy of relationships. I'll go into that in a second. Oh, here's a side note. Now, before everyone starts thinking, well, do I have to code? I can't code RDF. I don't know OWL. You don't have to. You really don't have to. Most modern taxonomy tools do this in the background. This is an example from Graphology. They do all of the SKOS, OWL, and RDF under the cover, so you don't have to code. Synaptica, Graphite does this. Pool Party does this. Top Quadrant does this. So don't get nervous if you don't want to code. Back to the semantic relationships. Within SKOS, you have some options, and one of them is to build relationships within a concept scheme. And that's your walled garden. And within your walled garden, you can have broader terms, a narrower concept, you have related concepts, and you have broader transitive and narrower transitive, which we'll get into a little later. But also, SKOS allows you to build relationships with other concept schemes. There might come a time, or maybe you're already doing this, where there's an enormous amount of industry or sector or open source ontologies and taxonomies that are available for anybody. And they are usually built and distributed by nonprofit organizations for the better of the good. Pharmaceuticals has a lot. The Pistoia Alliance comes to mind, where they have ontologies for pharmaceuticals, and you can imagine they're huge. And it could be that if you're a pharmaceutical company or a medical company, that you would want to import those outside taxonomies and ontologies and knowledge graphs and map them to what you have. And SKOS anticipates that and allows it. So you can bring in outside ontologies and begin to map related matches, broader matches, close match, narrower matches, so that you can begin to merge or meld without having to make one uber ontology, but by making relationships outside of that ontology as well. Basic relationships within a scheme. In your garden, there's a concept, okay? That concept will have labels. It can have a preferred label, an alternate label, or a hidden label. You can have that concept be a broader concept. It can have narrower concepts, and you can relate it to other concepts. When you're mapping relationships to a different scheme, you have different kinds of relationships. You have the exact match, you have the broad match, the narrow match, and the related match. Let's explore that just for a second. This is the example that is in the W3C SKOS specification itself, and it's so cute. I just wanted to share this with you. This is their example. In scheme 1, on the left, we have animals. And on the right, we have scheme 2, which is the egg seller's vocabulary. Now, they both have a top concept of animals, and that becomes the exact match. Under animals, we have platypus as a kind of animal as a narrower term. For the egg sellers, they have egg-laying animals. Now, the platypus becomes a broad match, not an exact match, and not exactly a related match. The platypus is an egg-laying animal, so that's considered a broad match. And the platypus also is related, a related match to eggs, because platypi, would you call it? Platypi lay eggs. But let's talk now about transitive relationships. Transitive relationships, which was, I spoke earlier, is about inheriting some hierarchical relationships by describing this as a broader transitive or a narrow transitive or an exact match. Those are the 3 transitive relationships in SKOS. And it works like this. If you have concept A is an exact match to concept B, say, and concept B is an exact match to concept C, then through SKOS, you can begin to infer that concept C must be an exact match to concept A. And this is the beginning of the power of inference. So transitive are super properties in SKOS because they enhance the structures. They facilitate inferencing, so you can begin to, in a way that's solid enough that you can build algorithms on top of it. It's particularly good for making recommendations, for instance. And it can contribute to some very nuanced organizational relationships beyond what you could do if you had to sew each relationship. So here's just a fun example. We have different ontologies here of who and content, and this one will be the distribution channel, for instance. So if we have a customer who has a certain profile, and of course the customer will have many attributes as to where they are on your, I guess, funnel, for a sales funnel. Are they new? Are they old? Have they bought things from you before? This is just an example. Has a certain channel like social media, say that that's how they like to get their information. And you have content with just the right tone and the right subject matter that would appeal to this customer. When that happens through transitive, then you can build algorithms that say, well, that if that's the case, then you can take this content for this customer and deliver it in this manner. You can have modular content now. I mean, we talk about books and we talk about videos and games, but there's also little blurbs that you might want to release in social media or in advertising. Content doesn't have to be big, but you might have some modular content that has the certain tone and the content that would appeal to that customer, and that can be automated and inferred. And then at the same time, you can say that we need to make sure that that modular content is delivered in this fashion. And as you begin to build these relationships and you build the content, it's very structured. All of that is very, very structured. The inference can take your relationships to a whole very sophisticated level. So why is SKOS important? It's important because there's no machine intelligence without knowledge representation. I think we can all agree on that. Taxonomies and ontologies actually teach the computer your point of view, your organization's point of view, your industry point of view, or even your sector. For example, a financial portfolio domain would have a very different relationship than that from a cultural heritage museum ontology, for example. But it represents a specific context, which has meaning that the computer can pick up on. And the taxonomies and ontologies are also one of the first steps in beginning to validate and teach the computer through machine learning how to automate. It could be a workflow, it could be recommendations engine, it could be omni-channel distribution, but it starts with good, structured, and standardized data. So in summary, thank you for your attention. Ontologies are great for modeling and storing information, have complex ecosystems that have complex workflows, or just have an enormous amount of data that you can build relationships with and begin applying those so that people can get the information and the resources that they're seeking as soon as and fast as possible. And the relationship, anything, you can make relationships with anything. So the best advantages of SKOS are concepts can have multiple labels with different kinds of preferences. You have relationships that go beyond just a taxonomical hierarchy. It allows for modularity within a scheme, so you can keep adding schemes to it if you need to be, and it can grow without breaking. And it also has readable descriptions that help the human understand what is this concept for and why am I using it? So it helps the human actually manage all of the data that serves the computer. Thank you very much for your attention on this. And I think Helen is going to be distributing all of our PowerPoints, so you'll be able to reference them later.
Yes.
Thank you so much, Maddie. That was so insightful, so informative, unbelievable. I've learned so much from that. I mean, I'd probably need another pass at it to really absorb everything you've just shared, but it's unbelievable information. Thank you so much for that. I think that the bit that we can connect to the most is the modular content, because that's what we do. We actually take the metadata tagged content and we create those chunks of content which can be automated and shared depending on, it could be, use the example of life sciences, for instance. You could be in a particular country where you have a language, but then you also have rules from the drug agencies on what you have to satisfy when it comes to content. So there's all these different variables where it needs to be served different pieces of content depending on what your output channel is and where you're actually sending it to. And that's where obviously taxonomy and metadata and tagging becomes really important. So I completely connected with what you were saying in that bit.
Indeed, in industries that are highly regulated, medical, food, having sort of structured content and the ability to be able to identify what is complying with regulators within any country. I mean, there are different regulations in every country. So it's not just, oh, well, we've passed one regulatory compliance test, but you'd want to be able to say, well, which countries can I sell this product now?
No, absolutely. And another thing, just to add on to the taxonomy as well, is that we're actually rolling out technology so you can use AI to automatically tag content with metadata. So once you've got, as you explained, all your taxonomy and ontology all sort of laid out and it's nice and tight and accurate, then you can use AI then to source through that data and automatically sort of generate and tag the correct ones to it. So that's another use case, as we talked earlier about AI and how it links into that structure.
That's right. There's the taxonomies in the background that teach the AI what's the entity extraction. Is it valid or not? It's not completely magic yet. I think we still need a human in there to be able to say, yes, good machine, or no, that was not right at all. But we're getting there and things are developing at a very accelerated pace.
We've got a couple of questions in the QA, so I don't want you to miss them. Sorry, Emerson.
Yeah, I was just about to take on to questions. So I think there was one from Joshua. I might need a bit of help with this. I don't know if you can see that yourself, Maddie, but
is it in the QA?
Yeah, so to what extent can we encode the same thing at more than one level in the hierarchy, or so that the full complexity of the relationships can be visible? That's the question, and then it gives an example afterwards.
That actually sounds pretty deep.
Yeah.
Well, let's see.
A good question.
Can you encode the same thing? Now, when we say the same thing at more than one level in the hierarchy, we call that polyhierarchy, right? We call that polyhierarchy. And I think I mentioned that in pharmaceuticals, a lot of different compounds, chemical compounds, can be listed in multiple places because it's used in multiple products or in medicines, for example. And so yes, you can encode them. And it has to be polyhierarchical in that instance. In that instance, it would probably be a good idea to try to encode not the polyhierarchy, but the display of it, so that you can see exactly where is that one concept used in multiple different places, so that you can say, I'm not a chemist, but I could say that this particular compound is in this medicine, it's in this pill, it's in this inoculation, and blah, 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 and you can see it that way. So yes, you can encode it in more than one place. I would use that in caution, because if you are doing it to sell, for instance, products over a website, you don't want it to be in too many places, or you will confuse the user. Less choice is more when it comes to dealing with your customers, is my opinion.
Good. Yeah.
But you also want to represent different mental models, so it's a very hard art, and it's definitely an art.
Right. Yeah, absolutely right, Alan.
There's a second question there from Shannon as well. Can you help me understand the difference between SKOS and OWL, i.e. SKOS concept versus OWL class, and when would you use either of these?
Controversial. I'm sure you don't even know that's controversial, but it's OWL and RDF are part of the SKOS standard. right? They're part of the SKOS standard. And OWL is the web language. And this goes into the linked data principles that if you deal with SKOS and you have the relationships that are also expressed in OWL, you could release that into the web and it will link to others that also are expressing the same thing. So, so that's beyond your walled garden. The controversy is that there's a lot of developers now who are just skipping over OWL altogether. They don't find that there's much value to it at all. Is that the RDF and the relationships are actually more important.
Yeah, my personal opinion on OWL is it was built for, you know, very heavy duty semantic web inference, and a lot of the use cases that we've seen coming through don't necessarily need that. They just need that proper description. Not to say that won't change, especially with AI. It's gonna need more structure and more graph-like structures, but I don't know the answer to Shannon's question either. I don't want to open a can of worms at this stage.
Well, I mean, schema.org, right, is Google's own sort of OWL in its way in structuring data that is for each industry, say, you know, that could be shared widely on the internet.
Yeah, when we're building our web pages, we stick to that structure, and it makes a huge difference because Google actually crawls for that, and if they see that structure in place, then we actually get escalated in the SERPs. Yeah, so we've hit a couple of featured snippets recently just based on the fact that we've put some good content, but we've stuck to that schema.org structure. So absolutely 100%. I think that's it for the questions. Helen, hand back to you. Thank you very much, Maddie.
Thank you.
Right, yeah,
it's a pleasure.
Yeah, we've got a couple of minutes. There was a couple of other comments I think it's worth bringing out. We've got so many industry people. So Heather, hello Heather, said it's also true that SKOS data model is an OWL ontology in itself, and that OWL predates SKOS. So just sort of putting the right chronology on it. But
thanks, Helen.
That's right. No, it's always just about finding the right tool for the job, isn't it? You know, we're a lot of us are very pragmatic, and yeah. Any other comments? Any other?
Oh, I wish we were in a room together because I could say, let's go have a beer or a glass of wine and continue our talk. This is, I mean, I wish we could have this conversation go on forever. And I really look forward to, if we can pressure information today to be able to install a real live in-person taxonomy boot camp, I would do it, Helen. It would be wonderful if we could.
Yep, that's a good sentiment. Yeah, I think this community is so chatty and so willing to share. I just absolutely love it. And that we draw from all sorts of different disciplines as well, in sort of digital and library science. And yeah. Okay, so we've got like a couple of minutes left, so I don't want to keep you, but thank you so much, Maddie and Emerson, for that session. That really, you know, it helps even me, who's supposedly been working with this for a long time. So that's really great. Thank you to all the speakers, all the moderators. Thank you again to Synaptica and Quark, who make all this possible. And thank you to all the attendees and everybody who's contributed to the chat. And as always, an absolutely fascinating discussion. Recordings and slides will be available soon. You will get them in a few days. It takes a little while to process, and then they will be out with you. And check out our website and social media, various places, for details about the Basics event on May the 1st and the subsequent events as well on 19th of June and the 9th of October. So a little way off, but do sign up, because I think we've got a really strong program this year. Thank you, everybody. It's been a really, really great event, and yeah, appreciate it. And have a great rest of your day, wherever you are in the world.
Thank you, Helen.
Thank you.
Thanks all. Bye-bye.
Cheers.